Alright, so today we're going to go over we're on Unit 6, Goal 2, and we're talking about similar triangles. So yesterday we talked about similar polygons, and we learned that in order for them to be similar, all the angles have to be equal, and the sides have to be proportional. And what we see with triangles, kind of like we saw with congruent triangles, is that we don't need quite as much information to say that two triangles are congruent or similar. So we used these three and a couple others when we were proving triangles congruent: angle, angle, side, 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 and side, angle, side. Well, there's similar ones for proving triangles similar. We can prove triangles similar, or say they're similar, by angle, angle, side, 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 and side, angle, side. So that just says if we have two angles congruent to two angles congruent in another triangle, then the triangles are similar. And once we know they're similar, then we can solve for missing sides, because then we know the sides are all proportional. Side, side, side says if all the sides are proportional to all the sides of another triangle, then the triangles are similar, which means all the angles are equal. And again, we can solve for missing sides. And then side and the angle in between, the included angle between two sides that are proportional. If those are proportional and equal, then they will be similar. So we're going to use these to solve as our goal today. So the first one is angle-angle similarity. Angle-angle similarity says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So we've talked before in class about how that our angles make up the opening. This is kind of like the hinge on a door, and that how far that hinge is open, that makes up the opening of the door. So if they're equal, then they're making a proportional opening. And you can actually use these a lot when you're trying to find distances in like surveying and so forth. So here we just need to know, is there two angles equal? We see there's 242s, so we need to know, is this third angle equal to 80, or is this F angle equal to 58? So just like we did before in angles of a triangle, we can take 42 plus 58, which gives us 100, and then 180 minus 100 gives us angle A, which is 80. So since this is 80, and that's 80, and this is 42, and this is 42, so then these are similar by the angle-angle similarity postulate. And then it asks us to write a similarity statement. And a similarity statement would be triangle ABC. So A was equal to E, so we'd have to do, there's our similar sign, triangle E. I have to do E first because E is equal to A. And then I did B. B is equal to D and F. Here we have two parallel lines. So first we can say these two are congruent because they're vertical. And then since these lines are parallel, these two are congruent because they're alternate interior. And actually these three, because of the third angle postulate, would have to be equal too. So yes, they're similar by our angle-angle similarity. And then our similarity statement could be, there's several you could put, but let's say QPX, so Q is equal to N, is similar to triangle NM, because M is equal to P, X. So that's the first part, saying whether or not we can say they're similar, and then if they are, writing that similarity statement. So two more. Side, side, side similarity says that if the corresponding sides of two triangles are proportional, then the triangles are similar. And side angle side says if the lengths of two sides of one triangle are proportional to the lengths of two corresponding sides of another triangle, and the included angles are congruent, then the triangles are similar. So here we're going to have to check some proportions. So here we can see right off the bat, anytime we see vertical angles, we can say those are for sure equal. So I have an angle. I can't say to another couple angles, so let's check to see if these sides are proportional to these sides. So when we're checking proportionality, we could go to 6 over 7.5. Does that equal 4, because that's smaller than 5, over 5? And then we can cross multiply to check that. So does 30 equal 30? Because 4 times, I should have written that out. Let's say I did 6 times 5 equal, checking to see, 4 times 7.5. And they do. So since they are, these are similar by side, angle, side, similarity. That's our explaining it. And then our similarity statement could be a triangle A, B, C is similar to triangle D, E, C. So we said AC is proportional to DC, so AC, DC. So, and BC here is similar to EC, so we can see that the proportional sides line up. And here, again, we have a shared angle, so this angle, M, is in both the NMP one and the RMS one. So we have an angle, so we're going to check our sides. Does 10 over 12, this side to this side, is that proportional to this side, 25, over this side, 30? And there's a few ways you could set that up. You could do 10 over 25. So I did small side to small side of the larger triangle, 12 over 30. You could do a lot of different ways to set that up. And then again, you're going to cross multiply to check. So it is 10 times 30. This is our question that we're checking. Does that equal 12 times 25? So 300. Does that equal 300? It does. So they are similar by side, angle, side. And our similarity statement would be, one of them could be MNP is similar to MRS. So that gives you some ideas on proving they're similar. Now let's use some of that here in our to solve. Some properties that also go along with similarity that we've seen before that happen if a triangle is always similar to itself. If a triangle is similar to another triangle, then that second triangle is similar to the first, because you can flip-flop them. Remember, symmetric. And transitive, if a triangle is similar to a second triangle, that second triangle is similar to the third, then the first is similar to the third too. So here we can check to make sure these are similar, because these are going to be equal, and because those are parallel, these are going to be equal. So since this tells us that their angles are equal, and by angle, we can see that those are similar triangles. So RQS is similar to TQS. So I can set up my proportion. Since I know they're similar, I know that 10 over 4 is going to equal 2x plus 10 over x plus 3. And then we solve by cross multiplying. So 10 times x plus 3 will equal 4 times 2x plus 10. So we can write our equation then. Distribute, so 10x plus 30 equals 8x plus 40. Let's get our x's together, so subtract the 8x. I always move smaller. Don't have to, but that's what I do so I don't have as many negatives. And then subtract 30. So 2x equals 10, and then divide by 2. So we had 2x equals 10, divide by 2, x equals 5. So we were supposed to find RQ and QT. Always make sure we found x. So RQ equaled x plus 3, but x is 5, so it equals 5 plus 3. And QT equals 2 times 5 plus 10. So 10 plus 10, which equals 20. So there's RQ and QT. So once you know they're similar, you can set up your proportion and then you can solve for x and then check back to make sure that you put in and solve for what you need to solve. So these are, there'll be a few more examples that we'll go over in class. So if you have more questions, just let me know. But this gives you kind of an overview of our Unit 6 Goal 2 Similar Triangles lesson. Thank you.